Okay, so order of I'm going to draw the cross section. I know that the faults cut across the unconformity and displace it, so I'm going to put F1 and F2 in first. Then I'm going to mark off the unconformity in the layers above, which is rock unit C, and then I'm going to do the folded layers afterwards. Okay, this is the cross section, and I'm going to start to transfer the information from my scrap bit of paper using the order onto the cross section itself. Okay, I've worked out earlier on that F1 and F2 cut across the unconformity and all the folded layers, so I'm going to put those in first. So I'll line up my section. F2 is here, F1 is there. Look back at the map to double check. F1's got to have a dip, but F2 is vertical. So let's mark in F2 first. It's a vertical fault. I know it cuts across the unconformity, so I'm going to extend it well into the air because it cuts across all of the layers. Again, straight away I'm going to label it down as F2. Now F1, I'm actually told in the exam paper it dips 75 degrees towards the west, which is towards X. So let's mark that one on next. So 75 degrees towards X, and it is there. So let's mark that one on now. Again, it cuts across the unconformity in all the earlier boundaries. So I'm going to extend that into above the surface, well into the air. It was there, but it's been eroded away. And I'm going to make sure that I label F1 on. Okay, so we've done F1 and F2. Next boundary put on is the unconformity and rock layer C above. We know that they're horizontal. So I'm going to mark on layer C where it occurs at the surface, and it is there on the cross section, and over here, there. Now, if we look back at the map, I can see that the boundary for layer C is there, but it continues along. I'm going to get stopped by the fault at the top of the map, and it gets placed down here, and again it starts there on to the right of F2, and it continues to portion C. That's Henry fighting with Black Cat. So let's put those on. We're going to get stopped by F1 and F2. C layer above, displaced F2, and it's displaced again F1 as to this point here. So rock C above, and it's displaced down here. So we can actually, at this point, I can actually mark on my boundaries. C is here, and C is down there. So the fault has moved down on this side, and this has moved up. Go to this fault here. C is lower on this side and higher there. So this side has gone down, this side has gone up. Okay, right, so I've got 3 areas now that I need to put the folded layers in. Which one should I do first? Well, I could do this side and this side. This is a bit more tricky because we've got to go below the unconformity and got to work out what's going on down here. I'm going to start on this side first because I've got more of the layers that I can see. Then I go do this side, and I'm going to go in the middle afterwards. So I know I've got to have an antiform in this area, and I've marked it on my scrap bit of paper. So the first boundary that I can mark in is E there, D there, and there's a little one underneath the unconformity at that particular point. These 2 boundaries are dipping 45 degrees towards X, and this one is dipping 45 degrees towards Y. So let's mark these on. Get stopped by the unconformity and stopped by F2. Oh, do this one again. Last one, crossed over the fold axis, is dipping in the other direction. It's there. let's mark the layers on so I know what they are. This section is E, this is D, A in the middle, and then I've got a little bit of D there. Now I can look here, I know I've got D and E boundary over on this side. I know how thick D is because if I can measure it. So it's about 1.8 0.8 millimeters. So on this side, 0.8, it's there. So that's where the D finishes and E starts. It's going to have the same dip, so I'm going to mark it in like that. And we put that layer in. Now, I know there's going to be an antiform, so I'm going to put the axis in. Has to be vertical because the dips are the same on either side. And there's my antiform put in. Okay, so now we're going to go back to the west of F1. What we know from the map, we've just got this boundary in. And if I look at it, it looks like I can predict where this boundary would be, and this boundary would be below the unconformity. So I'm going to transfer that information onto my cross section first. So it looks like it will appear there, and that one will appear around about there, and in the centre it will be rock unit D. So let's transfer it back onto this scrap bit of paper. So that's where the boundary would be, and another one here, and this is rock unit D, and looking at the map it should go 45 degrees in that direction. Right, let's mark this information onto the cross section. This boundary that I've got here is rock unit D on this side, A here, but then there's a change to D at that point there underneath the unconformity. So this boundary is going 45 degrees this way, and this one is going 45 degrees in that direction. Put that on. 45 there. Again, it gets stopped by F1 and by the unconformity. Let's put this one over here, 45 degrees there. In this direction. So again, I can put my fold axis in. It should be vertical, splitting the area up in half. It's an antifold. Right, so things that we can do now, we can finish off this area. I know it's 0.8 centimetres here for that thickness, so I can, that's where E would start. I'll do it on this side as well. 0.8 is around about there, and in fact that sort of fits in where I predicted the other boundary would be. Right, this middle bit here, a bit more complicated, but we can use all the information on the cross section to work out what the structure is going to be down here. This fold axis gets stopped, or the APT I should say, gets stopped by F2, so I'm going to ignore that one. It would never make its way onto the cross section, whereas this one would. So I'm expecting to have a sinful in this area here. Now, what we're going to use to put this in is we're going to use the throw of the fault and displace the beds accordingly. So C has been displaced. The throw of the fault is 2.1 centimetres. So this means that on this side everything is going to be 2.1 centimetres lower. So I'm going to go to the ED boundary here, measure 2.1. I'm going to put a dot on the fault because that's where I'm going to expect the ED boundary to be. I can measure 45 degrees from that. I'm going to draw a little line out, not all the way down because I don't know where it's going to come back up again. Put a line in there, put E above it and D below it. I'm going to measure 2.1 centimetres again from the A boundary on this side. 2.1's there. So it's going to finish at that portion of the fault. I'm going to measure 45 degrees in again. And measure it there. So this is A, D, E. Now I know it's going to go down and it's going to come back up again. I need to mark in the other boundaries on here to know what I'm going to join things up to. So likewise, I'm going to use the same method as I used over here on F2 on F1. I'm going to measure the throw of the fault. So 0 is going to be 1.8 centimetres. So this AD boundary we've got here is going to go down 1.8 centimetres. So there is 1.8. It's at that depth along the fault. Notice I haven't measured along the fault because it's dipping. I've just measured the vertical throw. Now this layer that I've got here is going to dip 45 degrees in that direction. It's got the same dip as on the limb of that particular fold. It's there. So I'm going to join those up. I'm going to take it a little bit further this time because I know that's where things are going to go. I've got A on this side and I've got D here. Now the AD boundary is the same as the AD boundary here, so this layer boundary is going to join up with this one there. Let's continue this down and hopefully that will join up, and it does. So one more boundary to stick in. We know this was 0.8 centimetres, so I'm going to measure 0.8 in here to put the top boundary of D in, because that's the only one that's missing from this side. There's E, so this one's moving down. There's our fold, our sinful, which we predicted off the map. So I'm going to put the fold axis in. Again, it should be vertical, but remember it gets stopped by C because C is younger. Right, and we've finished.